So just walk.
Hi, I'm Michelle Cho.
And I'm Megan Howe.
And we're going to teach you the physics of dance.
Not this kind of dancing.
I wanna see how you lose control.
But this kind of dancing.
We'll find another way to dance. We'll find another way to dance. If you get the chance, you must dance, dance, dance. We'll find another way to dance. Find another way to dance. If you get the chance. If it takes away the pain, it's alright. Are you so hard, you might not make.
Before you begin dancing, stretching is required. Stretching warms up the muscles and allows you to become more flexible. And then step back, you ready? And then touch the floor.
It's impossible.
The key to dance is balance. Balance is an uneven distribution of weight, enabling someone or something to remain upright and steady. And in order to achieve balance, you need to have zero torque and zero force acting upon the dancer. The forces that act upon the dancer are the force of gravity, which pulls the dancer down, while the force from the floor pulls the dancer up. The friction from the floor creates a horizontal force as well. And more friction is caused by the grip of the shoes, so the dancer does not fall. But in order to continue moving, the friction must be decreased through marley, a smoother surface than wood of tiling.
Rotational inertia and torque is exerted against the floor. This torque also causes angular velocity, which produces the turning motion. Torque is what keeps the object spinning. The more force is applied, the faster the turn. The further the distance from the axis, the more quickly the object will accelerate. This is why it's easier to turn from fourth position rather than fifth position. For this reason, it is essential that the dancer stands on the balls of her feet and the big toe, rather than the outside of the foot, because the surface area is larger, so it's easier to maintain your balance. And also, your legs don't give out.
Rotational inertia is the difficulty of starting and stopping a turn. The equation for inertia is mass times the radius squared, which means that the greater the mass, the greater the rotational inertia. And the greater the distance from the rotation axis, that will make the rotational inertia 4 times as great.
When learning to turn, we usually start simple, one turn. This maintains static balance, so it's easier to get used to where the dancer's center is. Slow turns equals less number of turns though. As we become more advanced and find our center of gravity, we will start to turn faster in order to produce more turns. This is because faster turns results in a less wobbly rotation axis.
As you can see, it's not so much the momentum that gets the dancer around, but the way the dancer holds herself above her center of gravity and her rotational axis.
Alright, so point aside is your preparation. And touch.
Advanced turns, such as fautes and alcicants, are harder to accomplish because the radius is constantly changing. In a faute, you start off in a piqué, or a regular pirouette, and then you stretch your leg out as you turn, and you're constantly bending your leg and stretching it back out. With alcicants, your leg is constantly straight, so the radius is always twice as great, so it's harder to keep your rotational inertia.
Just a small town girl living in a lonely world. She took the midnight train going.
Newton's third law says that for every action there is an equal and opposite reaction, meaning that when you jump off the floor, you're pushing against the floor while the floor is pushing off of you. And the harder you push on the floor, the higher you will go.
Took the midnight train going and don't stop believing. Hold on to that feeling. Streetlight people. Oh, don't stop believing. Hold on.
Gravity acts as the vertical force of a leap. The movement of the leap creates a parabola where velocity equals 0 at the greatest height of the leap. There must also be more horizontal than vertical movement. Greater mass equals the greater gravitational pull. So, if you're larger, it's harder for you to get as high in a leap than a smaller person would.
Momentum is also a big factor when you dance. It affects leaps, and because we use sachets before our leaps so we can have a bigger velocity, which results in higher leaps and more time spent in the air. The formula for momentum is mass times velocity, so the greater the mass, the harder it is to stop. Momentum also affects turns, such as Al-Sakans, and this is because the more momentum there is, the more turns you can complete.
Momentum is also used during floor work. Notice how Michelle reaches forward before she flips over so that she can increase her velocity in order to increase her momentum. This enables her to flip backwards without falling out.
Oh my. Shape is also a factor that affects turning. Pirouettes require a rotational inertia, and rotational inertia is equal to the mass times the radius squared. The larger you are, the more inertia is required. This is why it's harder to turn. This is crucial in order to completing multiple turns in an astonishing fashion. This is why most ballerinas try their hardest to keep fit. This doesn't mean that bigger girls can't turn, it's just that it requires them to do more work.
The most important part of dancing is to be yourself. Even if you're 4 foot tall, and even if you're Asian, Indian, white, brown, black, yellow, any color. Green, purple, any color.
This has nothing to do
You
with
just have to be confident in the way you dance. And remember, apply physics to everything you do, including dance.
Yeah!
Do I attract you? Do I repulse you with my queasy smile? Am I too dirty? Am I too flirty? Do I like what you like? I could be wholesome, I could be loathsome, guess I'm a little bit shy. Why don't you like me? Why don't you like me without making me try? I try to